And so we are continuing.
Антон,
Let me present two next speakers, Anton Guglia and Evgeny Kivtenko from QAP.
Спасибо.
Коллеги, здравствуйте.
Thank you. Colleagues, hello. Good day, everyone.
Меня зовут Антон Гугли, я руководитель
My name is Anton Guglia. I'm head of QAP. And here's Evgeny Kivtenko,
про квантово-устойчивый.
head of the investigation groups. Today we're going to talk about a quantum resilient blockchain. What's the difference between this and traditional blockchains? What does a quantum computer have to do with it? And why are we talking about quantum computers
Спин-офф
in
российского
terms of attacks? A few words about ourselves. QAP is a spin-off of the Quantum Computer Center. Quantum Computer Center is a leading organization for quantum technologies. We've already started the first quantum computer in Russia. We do information security solutions there as well. We're also part of the Technical Committee 26 to develop standards of post-quantum cryptography. A few words of introduction, and then I'll pass the floor to Evgeny. You understand what a quantum threat is and why quantum computers is not only a good thing, but it's also an evil thing in the hands of a bad guy. A question to you: who knows what a quantum computer is? Who's heard that in Russia the first experimental quantum computers have been launched? Great. Evgeny, then over to you. Thank you.
Я, может быть, так
So,
напомню.
let me briefly remind you.
Так довольно.
Perhaps the subject is quite well known, but what's the whole idea of this
Вот, собственно, в начале
activity? In the beginning of the 20th century, when they tried to understand how microscopic world behaves, it turned out that the notions, the laws that had been used before that,
уже начинает не работать.
turned out not working, and we needed a new way to describe our world. And turned out that this way of describing the world
Они начинают так противоречить.
started to get into contradiction with the our classic intuition.
Может наш мир функционировать.
So about how our world operates.
Что
And it turned out
квантовый мир ведет себя совсем.
that the quantum world behaves absolutely differently, which led
Аппарат классический
to a situation where the
лежит в основе
apparatus and calculus of a traditional theory of probabilities, that's the foundation of information theory, should become the foundation of this area. And we're now arriving at the theory of quantum information. Turns out that this quantum world opens new vistas to
информация.
understand what information is all about.
Вот эта вот идея квантового.
From where the idea of a quantum computer appeared. Maybe the whole name is a bit misleading, because if you take all these devices that we're all using, they're also quantum-based, because an elementary transistor that is based on its description is also based on the laws of quantum mechanics. But nevertheless,
аппаратуры.
in case of the traditional
Да, и
equipment, we deal with so-called collective effects,
при этом та логика, которая
but the logic that we operate is,
классическая, да, то есть мы оперируем
on the whole, classic.
случайно.
We operate with random discrete values. But the idea of quantum computing isn't that we start operating with separate objects. And these separate quantum objects are used to store and process information. Here you see these points in the picture. These are 4 captured particles, and each of these particles is used to store information.
Состояние
And so, because the state of these particles,
для несправедливо квантовые законы,
because they behave governed by quantum laws, is more sophisticated.
вот эти
So there are conditions of superposition, just like in Schrödinger's cats, that can be dead and alive at the same time.
работать. И
So it turns out that you can work with these bits. And based on these bits, you can implement new
описание, да, и
algorithms
новые возможности.
that are described in a novel way and offer new opportunities. I just wanted to say
не
to colleagues who haven't heard and who is not deeply involved in the development of quantum computers, that in the world, a lot of different architectural
холодные атомы.
approaches are being used to develop a quantum computer. There's no single architecture, and they're all developing on parallel. Also, there's this approach of quantum-inspired algorithm, when algorithms
Кластера, то есть традиционные
inherit from quantum computing logically, but hardware-based, they are just based on normal CPUs and GPUs.
аппаратные,
So research is being
она растет, она
done that so as to develop different ways of doing quantum computers. And when quantum computers are being built, Russia is lagging behind for now, but the first quantum computers have already been created, and you can even look at them in a lab. So these are technologies that
фундаментальных исследований
came out that actually went beyond, purely theoretical and purely research activities.
И вот переходим к тому,
And here we arrive at a point that, on the one hand, the whole world is trying to apply quantum computing right now, if it's possible, or within several years from now, in order to solve those problems that are too hard for classic computers. For instance, optimization task of very large dimension. These could be tasks about modeling new medications, neural networks, and it looks like these tasks are being solved with classical methods, but they're close to the limit, whereas quantum computers are seen as a tool that can solve them much faster. But we are not going to talk about the good side of quantum computers, but rather about the dark side of it, the opportunities that they offer bad people to do illegal activities.
собственно, когда
So,
родилась вот эта вот идея,
when this whole idea
что можно,
was born, a question
каких там
arose: how these quantum computers can be used in terms of
оказалось,
algorithmic tasks.
в
It turned out,
20 века был
well, basically it happened in the 90s of the 20th century. A famous algorithm was proposed by Peter Shaw to solve two tasks. Firstly, to solve the problem of factorization. So if you have a large natural number that is a product of two prime numbers. So this allows.
это алгоритм
And second was the algorithms of discrete
вот.
algorithm.
Там для человека, который так не
So for a layperson,
ну, какие-то
it can seem, so what? These are abstract mathematical problems. But then it turned out that these are the problems that form the foundation of asymmetric cryptographic primitives that are being used everywhere today. So this is an interesting case. It's just a fact. The algorithm is already there. All the steps have been described. It has been proven that it has a finite complexity. And so the only thing that's left to be done is to launch it. So we just need a quantum computer to launch this algorithm. Actually, it was tested at that time. The first result was, for instance, they, produced 15 as a product of 5 and 3. Actually, nobody was surprised. Of course, everybody knows that 15 is 5.3. But this was the result of solving this task. But ultimately, the situation arrived to the point where the quantum computers are powerful enough to
компьютеров, которые
present problems for decoding. And the number of quantum computers that you have seen in media
доступ. То есть
Cloud access is provided to them. It's difficult to get this access from Russia, but within the countries where these quantum computers are built, it is possible. And cloud access to quantum computers in Russia from Russia is also possible. So basically, it's also available for potential
использовать удаленно.
malefactors. So this strengthens the risks that the bad person can get access to multiple quantum computers. One of the direction of the developments is a platform of common access to quantum computers. Translators, interpreters are being developed to run computing on quantum computers. Even in Russia, there are several such platforms at the moment.
Да, здесь еще раз представлены такие.
This shows once again the main attack vectors here. Firstly, it's a forging digital signature, which, for instance, is built on elliptic curves. Then, in the blockchain context,
Знаменитый алгоритм Grover
there's a famous Grover algorithm.
называют,
It's an algorithm of search.
который
It's a universal algorithm that simplifies enumeration.
ящика вам нужно перебрать.
For instance, you have a classic black box and you have enumerate 2 to the power of n codes to get the element that you need. So if this black box is implemented in a quantum way, it turns out that you don't need 2 to the power of n, but rather a square root of 2 to the nth. So
Да, но тем
simplifying the task.
случае, ну и вот там, во всяком случае, в такой в академической литературе
So at least in academic literature, this is considered as a potential threat, that this Grover algorithm can be used to do the 51% attack. And also the fact
Шора, по сути, может
that Shor's algorithm
подпись,
can forge or counterfeit a digital signature may mean that contracts can be forged and
комментируется.
criminals can gain access to electronic wallets.
Именно
So
в контексте
this is what's the importance of this for Bitcoin?
компьютеров пока нет.
Quite often you can hear, so guys, come on, there are no quantum computers as yet. So by the time they build powerful quantum computers, we'll think of something.
В общем, да, когда все будет,
But when
мы поймем, что
when we do understand that quantum computers are about to happen, by that time we'll know what to do. Because so far, the quantum computers that are in existence, they're actually quite weak, and they can be simulated on classic computers. But why the interest of blockchain? This is an example.
в нулевом
It's the first transaction in block 0.
смотреть на именно
And if you take a look at Bitcoin,
Да.
because this slide was Bitcoin,
блоков, которые вот
there are several first blocks
всю эту систему запустила, там просто вот
when they launched the system. So the first several blocks, 50 bitcoins each, were accrued for the fact of mining. So what's interesting is that the first transactions
начислялись эти монеты,
where these coins were accrued were built following the public key principle. So
собственно,
this money could be taken by the person that can sign the transaction with a key that matches this public key. So what's the understanding? So probably Nakamoto will hardly take these coins. But on the other hand, it's also clear that these coins will be taken by someone who will get a quantum computer that will be powerful enough, and nothing can be done about that. These transactions are in the blockchain. You can't remove them. So basically, it's kind of a prize that's hanging there for the first one who will be able to create a quantum computer powerful enough to
проектирование.
calculate this key. So this is a kind of an error in this architecture. And in terms of blockchain, it's important because we won't be able to change it. public blockchain. So this is just a curious fact to know.
От
This said,
компьютеров,
getting protected from the quantum computer threat,
технологий, но мы
you can use different technology stacks. But today, we are focusing on quantum cryptography, hardware solutions in the first place to distribute cryptographic keys over fiber lines.
что вот текущий этап
So the current stage of quantum technology development gave the world an opportunity by managing single particles to pass information such as cryptographic keys. And the other class of technology is a post-quantum cryptography software. Solutions are based on new classes of symmetric encryption. So you don't need to modernize the infrastructure. You don't need any new hardware. There's nothing quantum in the new infrastructure, but what you get is a new class of asymmetry that's resilient to attacks initiated from quantum computers.
Постквантовый
So, and here we are considering these two areas: quantum cryptography.
роде защищаемся новой физикой,
What's the essence? We kind of use new physics that get protected from new threats. We use quantum effects to get a new way of distributing asymmetric keys,
метричных ключей.
because quantum cryptography is basically focusing on the distribution of asymmetric keys. So the solution looks like two boxes connected by a fiber cable.
Что они делают? Они просто
And at the output, these two boxes just issue asymmetric keys
ноликов и единичек.
to
Гарантируют
remote users.
физики, что вот
And it's guaranteed at the level of the laws of physics. There's these bit sequences
по правильности функционирования.
with certain assumptions
Единички, они действительно
that these zeros and ones will be indeed secret, and no party in between will be able to interact with this information.
она никакой информации об этих ключах получить не может.
при этом сейчас
Get no information about these keys. And now there are pilot solutions when the key is described not only over fiber line, but also over open satellite links worldwide and in Russia. Such solutions are already piloted.
Когда мы, собственно,
So,
в свое время я как раз работал
historically,
в постобработке для квантовых.
I used to work on the post-processing of quantum keys, and I was interested where quantum cryptography can be used for applied purposes. And that was the time when we first heard about blockchain from mass media, started to figure out how it works and what it is and what can be done with it. And then the
Такой
first such approach that we proposed at that time, how you
систему,
can build such a distributed system.
именно блокчейном, но тем не менее.
Maybe blockchain is not altogether the right name for it, but it's a distributed ledger that could provide
Стойкость, то есть
the
доказуемость,
resilience and stability level,
доказуемость которого не содержится на
the
каких-то
protocol that is not based on any
такой информационно-теоретической стойкостью. В плане, что есть.
assumptions about the hardware structure.
Вот аналогичным образом мы использовали
So
протокол, который
we proposed a protocol
строить такой
that use symmetric keys to build such a distributed ledger. Its functioning
согласие, такой один
was used
80.
as a Byzantium agreement,
Собственно,
Byzantium consent proposed in the 80s. And this protocol function, its security has been proven if the number of
вот
non-bona fide users is less than a third of the total number of users.
чем
This protocol went further than just research and was piloted with Gazprom Bank in Russia. The first such experimental network was built in Russia,
квантовых коммуникаций
where quantum communication solutions were used to
распределение
well, in combination with the distributed ledger protocol.
ссылок, если вам будет
And we have an addendum to this presentation with several links to research papers that you can
больше про аппаратные решения
read at your leisure. And so
криптографических
hardware solutions are required for the distribution of cryptographic keys. Fiber lines can be used, open channels can be used. One other thing I'd like to say about post-quantum cryptography, that it can be used just like a standalone solution, and it can be used synergetically together with quantum communication. For instance,
защиты
using post-quantum cryptography to protect the last line, last mile,
вместе объединяя.
bringing everything together.
Квантовую угрозу кто-то из вас
Quantum threat.
услышал первый раз
Somebody, some of you have
актуально во всем.
heard about it for the first time today, but actually this is the theme that has been worked on worldwide, and many companies and countries are trialing quantum-based solutions.
Публично
And perhaps of the most interesting public documents that you can find to verify the veracity of what you've heard from us is that in March a new document was published in the US, and they updated their policy for the transition to quantum resilient solutions. And this was happened quite fast. At the end of 2022, they had a prospect where the US said that we will develop this strategy, we'll show to the world. And in March this year, the strategy was already published. And worldwide, there are a lot of projects related to quantum resilient solutions. And not all of them are about blockchain. Some are devoted to VPNs for government organizations. In other places, they pilot solutions for banking networks. But quantum
поискать кейс.
resilient solutions are part of them. So if you're interested, you can go through these companies' resources, and such companies, Google, IBM. There's been a very interesting pilot project, Cloudflare. A lot of traffic goes through Cloudflare.
Сейчас не совру, до 20%
If I'm not
общего трафика.
mistaken, 20%. They protected 20% of total traffic with quantum resilient solutions. As part of standardization institutions such as NIST, an international institution developing encryption standards, processes have been launched to develop algorithms to identify the most resilient algorithms that can be used to protect from quantum threat. So this is a very hot subject. So if you're interested, please, do your research. In conclusion, I'd like to say that quantum resilient solutions can be used to protect blockchain solutions, either proprietary or public blockchain. We in Russia have already started working with domestic vendors such as MasterChain and Waze, and we already have products that allow doing that. So if you're interested, we invite you to these pilots. We are prepared to discuss them. We're prepared to offer our products.
Если вам
So if you are interested, we are prepared to discuss the formats of even non-commercial testing and trialing. This actually brings us to the end of the presentation. There are some more technical slides to follow, but we are ready to take your questions. Yes, thank you for your presentation, Yuri Korlякov, Niksev. Victor, you mentioned the problem of solving the discrete algorithms. As far as I know, this problem is now the foundation of resilience and RSI cryptography. There's no algorithm that would allow solving this problem other than by complete remuneration. Is my understanding correct that quantum cryptography doesn't invent a new algorithm, but it just allows doing this remuneration much faster, like say doing it in 1 year instead of 100 years. Quantum computing allows doing that. So new hardware allows speeding up the computing, whereas
барьером для
quantum and post-quantum cryptography solutions can be used to build a tougher barrier to do that. So this is actually
Не сработало так эффективно.
the situation of competition.
Давайте.
То есть, смотрите,
Look,
что касается факторизации дискретного
as to the factorization of discrete algorithmization,
сложности.
algorithms, specific algorithms were shown that have polynomial complexities.
И
It's
пока
not about remuneration. It was just algebraic structures, and it
преобразование
was
форм
shown that this algebraic structure fits very well what the quantum computers can do.
фотографии
It's basically about Fourier transforms. So quantum cryptography is an approach where we go away from algebraic operations. It's mostly based on physics. If
другой совсем.
somebody has measured it, they will spoil the result and will notice it. So
Про проблему.
thank you. Is my understanding correct that the problem, you're talking about the problem of distributed keys.
Получить двум сторонам.
So now it's almost standard. So when
Понимаю, что
is it the Diffie-Hellman algorithm is used if both parties need to get a secret key on. So is my understanding correct that we're moving from Diffie-Hellman to new physics? Yes, absolutely correct. There are a lot of different approaches, but the essence based on different mathematics, but the essence is like this.
Фотографии, например,
The post-quantum cryptography solutions are our own,
один как
but we look also at solutions proposed in other countries. They're not based on different on the same algorithm. We ourselves have products based on 8 different algorithms. So this NIST contest that's being run since 2018. They accepted about 70 algorithms at the output, and so the cryptographic community is working to identify the best of them. Now there are 10 left, and looking forward, there will be even less.
мало того, в пилотных проектах иногда и
In
совмещают.
pilot projects, sometimes they combine them even with a ghost algorithm, combining the algorithms from a traditional cryptography and quantum-based.
для
And the last question.
бы
So
12 бит.
uh,
Защита
making the key longer up to 512 bits, will it be secure enough to protect us from post-quantum?
Что
No. It has been shown that the complexity is polynomial
в том-то и дело, что
for the length of the key. So this is the point that just by growing the key length, we won't be able to solve this problem. Thank you very much for your presentation. My name is. I didn't quite understand what you said about Grover attack, because if it's one computer, it's clear that the malefactor has the advantage. But if there are many quantum computers, we're just making blocks faster. The complexity grows, and there's a question about the resilience of the network. So my question is, there's classic cryptography, there's post-quantum and quantum. So, in your opinion, is there just one of them that will stay, or niches will be found for everyone?
Наша позиция, вот как компания, которая
Our position as a company that makes those things is that
время минимум несколько
now and for some time, 2-3 years ahead,
совмещая
hybrid approaches will be used
постквантовые
that will
совмещается,
use everything.
как я уже говорил,
Post-quantum cryptography will be merged with quantum cryptography to protect from MITM attacks, and last mile attacks. And then it will be merged with post-quantum cryptography.
разрабатываются
With
государственные
both quantum and post-quantum communication, there are government standards appearing. So with quantum cryptography, we have first vendor already
сертификат
finishing the certification process.
с получением
And this has to do with it. So if you have the government algorithms and the
ну, Женя,
regulator will approve those solutions,
постквантовые
means that the quantum communication and post-quantum
и они
cryptography will become commodity technologies, and they will push out the current cryptography just because of the development of
небольшая, но
of the technologies.
криптография, например, симметрическая
One more question. Currently, asymmetric encrypting,
квантовая.
SHA-2 and 3, are currently post-quantum. We believe now that even the quantum computer will not be able to hack those algorithms.
Добрый день, спасибо за доклад. У меня вопрос.
Hello, thank you for your presentation. My question is,
Э,
do I get it right that
Шифрование
ensure
всё равно понадобится
quantum-protected
компьютер, и
encryption, we will need a quantum computer? This will be a privilege of those who have
применяем там
that computer.
способы,
Like currently we are using AES and other traditional cryptography.
ну, такой
Average user will not be able to
нам не требует.
use the quantum encryption. Well, to protect,
Нам
we
требует
don't need a quantum computer, but to attack,
точно
they
констатировать
need the quantum computer. So
атак. Это
we
привилегия
can state that
доступ к
using those attacks is a privilege of those who have access to powerful quantum computers. So there's a hypothesis that no one knows what is the top
архитектуру, на которой это построено,
power of the quantum computer because of
в паблик.
probably no one will even publicize this, the amount of qubits, the architecture. Probably there are even more powerful quantum computers like Osprey 443 qubits and other architectures. So the advantage of those who has them,
Так мы думаем.
those who will use
Еще
them
коррелирует с
for
тем,
attack,
как дипфейки
is can be very significant. And this also correlates with the deepfake and how they spread in the other countries, because the technology is tested in a closed mode and then it's open for everybody. So there is a probability that those computers exist and are being used, but it's a secret. So
мы уже пилотируемся, да,
that is why we are piloting currently
по блокчейну
with blockchains. We work with blockchain vendors
количество
and with a lot of other
процессоры там.
types of solutions,
Это ВКС,
modern local processors, Baikal and others, VKS, the conferencing systems and banking systems. So we run our pilots with a lot of
если вот мы говорим,
solutions to not be late, because
но требует
switching to post-quantum cryptography does not need to change an architecture, but you need to
интеграции,
explain this to security services. You need to integrate with
обращение к новым.
crypto providers and a lot of other stuff. So
Это даже, ну, в первую
we
очередь.
need to develop the standard, and in Russia especially, we need to approve quantum cryptography as a standard. It's late
Поэтому
if we start when the computers start, the quantum computers start their attack. So that is why we are focusing on the current solution. So there was a lot of questions. Let me
да, по-моему,
take one more, and
закончим на этом.
then we finish the presentation.
Спасибо за доклад. Я хотел спросить вот в этом...
Thank you. Thank you. And my question is, in this consensus algorithm, quantum resilient algorithm,
Или для передачи...
where are they used?
например?
To find the message or to pass the message between the validators?
Вот то, что мы
Well,
сделали,
if we talk about
на самом деле вот это решение, оно чисто
our work, our solution is
на использование квантовой криптографии,
based on quantum cryptography, asymmetric, symmetric key.
именно постквантовой
There's no post-quantum cryptography.
постквантовой
The only moment where it appears is
первый
for the devices that spread the keys on the first round when they need to authentify, they need something else. So this is the moment when we use
Спасибо большое.
quantum cryptography.
Когда много вопросов,
Thank you. Thank you indeed. And it's great that you have a lot of questions. Please choose the one that you like the most.